Well, a very good afternoon, Donald. Let me introduce myself, Jason. I am from the Department of Electronics and the Communication Engineering. Today, I am here to say about the what is meant by signals, what are the classification of signals in the codes of signals and the systems. So, first of all, definition and classification of signals. So, the first of all, then briefly introduction to the signals. The signals are the functions that convey information about the behavior of a phenomenon, and there are essential in various fields such as communications, control systems, and signal processing. And then the next point is the understanding signals, helping in analyzing and transmitting and processing data efficiently. Next is what is meant by signal. Is basically signal is a time varying physical phenomena which is integrated to convey information. Signal is a function of time. Signal is a function of one or more independent variables which contain some information. For example, you can say that voice signal, video signal, and signals on telegram, wires, etc. uh, for example, the noise is also a signal, but the information conveyed by noise is unwanted, hence it is considered as unsayable. And a signal is a time or space varying quantity that carries information. It can be represent it can be represented mathematically as a function of one or more independent variables. The signals can be continuous or discrete depending on their domain of definition. The next is the types of signals, the continuous time signals. So the continuous time signals are defined for every instant of time within a range. They are typically represented by functions like x of t, where t is a continuous variable. For example, include analog audio signals and voltage waveforms. The next is types of signals, discrete time signals. The discrete time signals are defined only at a specific and separate points in time. They are represented as sequence such as x of t, where n is an integer. For example, include digital audio recordings and sample signals. In right side, this is there is a sum of the table is given below. The discrete time signals. The discrete time signals can be measured at regular intervals in a discrete time signal. There are n second gaps with no data. DT signals or x of n. Discrete signals replace CT signals. They have less information. They need less memory. That like the next is classification of signals based upon their nature. So the signals can be primarily described by a mathematical expression. The random signals exhibit variability and or described by probability functions. Both types are essential in different applications such as control systems and communication. And then the next one is the classification of signals based upon the periodicity. So the pediatric signals, basically the pediatric signals are known as an important class of signals in the class of pediatric signals. A pediatric signals is a continuous time signal x of t that has a property that means x of t equals to x of t small t plus capital T, where capital T is greater than 0 for all t. For example, cos into t plus 2t that equals to cos into t. So the next is sine into t plus 2 pi that equals to sine into t. The are both pediatric with period 2 pi. For a signal to be pediatric, the relationship must hold for all t. So the pediatric signals repeat their pattern after a specific interval called the period, and a pediatric signals do not exhibit any repeatedly pattern over time. Pediatricity influence the analysis and processing techniques used for these signals. And then the next one is uh, based on power. Based on power means the power signals have a finite total energy but infinite total average power. Energy signals have a finite total energy and zero average power. This classification help in designing and analyzing signal processing systems. The next is based on energy. Energy signals have a finite amount of energy over all time. Power signals have a finite and non-zero average power over time. The distribution determines how signals are analyzed in systems. So the next is based upon the modulation. The modulation signals are variations of a carrier wave to transmit information. Amplitude, frequency, and phase modulation are common types. The modulation techniques are foundational in the communication systems. So the next is continuous versus discrete signals. The continuous signals are defined at every instant, representing analog phenomena, and the discrete signals are sampled variations suitable for digital processing. The choice between them depends on the application and the system design. The next is analog versus digital signals. The analog signals have a continuous range of values representing real world data. Digital signals consist of discrete levels enabling area processing and transmission. Digital signals are lesser to noise and easier to manipulate. And the next is the applications of different signal types. The continuous and analog signals are used in audio video transmission. Discrete and digital signals are prevalent in computer processing and digital communication. And then the next is the understanding the classification acts in selecting amplitude processing techniques. The next is importance of signal classification. Proper classification simplifies analyze and system design. It's apps in choosing suitable processing algorithms and hardware. Understanding signals ensures effective communication and data integrating. The next is a summary of signal classifications. The signals can be classified based upon the time domain, power, energy, and the modulation. Each type has specific characteristics important for system design. So, and then is the this classification helps to put signal processing stabilities. The next is reference. And then thank you for your attention. Thank you so much.